So the first section was, we had parallel lines, remember? How do I show that those are definitely parallel lines?
The play button.
Yeah, the little play button. And most of the time, it's red, but, okay? And then do you remember what we called this line that went across those two parallel lines? Close.
Transversal.
The transversal, right? Okay, so why are parallel lines parallel again?
They never touch.
Don't tell me that they never cross. Why? Because they have the same slope, exactly right. So they have the same slope, so they will never cross, but they're not parallel just because they never cross. It's because they don't have the same slope. So remember then we had little numbers all the way around here? Okay? What would we call 4 and 6?
Adjacent angles.
4 and 6.
Interior,
Alternate.
Exterior.
Now, are they on the inside or the outside of my parallel lines?
Inside.
Inside, so alternate interior. Why is it alternate?
because they're on the opposite side.
Because they're on both sides of the transversal, right? And then they're on the inside. So, give me an example then of alternate exterior angles. 1 and 7 would work. Everybody agree?
Yeah.
What else? One more.
6, 8.
8, 3, 2.
2 and 8, right?
Oh,
2 and 8. They got to be on the outside, all right? So, what would we have called 2 and 4?
diagonal.
Adjacent.
Okay, they're diagonal.
Oh, no.
But what did it mean when they were diagonal? Vertical angles, exactly right.
Vertical, even though they don't go.
What happens if they're vertical angles?
They're the same degree measure.
They're congruent, right? Or the same degree of measure. I don't know, that's a good question. Okay. Finally, Mr. Galvin, you've said it every other time, what would we call 2 and 3? Say what you've been saying.
Adjacent.
Adjacent, right? What does adjacent really do for us? Not a whole lot, right? Adjacent just means they're right next to each other. They share a line, but they really don't do anything. So get adjacent out of your melon. All right? Don't think about them. So what can we also call 2 and 3?
Complementary.
Supplementary, because why?
That's
It's
180.
one line and they add up to
They make up one line and they add up to what?
180.
So supplementary angles add up to 180. What's kind of the opposite?
Complementary.
Complementary, and they add up to?
90.
And how do we definitely know about them?
They make a right angle.
So they have a
Box.
box, right? So they have the little box in the corner, all right?
Could you have a transversal that goes straight up and down?
Absolutely. Because if I have this transversal going straight up and down, this brings us to our other word, right? Then we put a box here and a box here, and we would say that this transversal to our parallel lines is what? Okay, what else? Begins with a P. Not parallel, but what? Perpendicular, right? When lines cross at a 90-degree angle. So absolutely you can have that. Okay? Did I miss any? Can't remember. I think we hit most of them.
Corresponding.
Oh, corresponding is a good one. So we go back to our sets, and what are a group of corresponding angles? What's corresponding mean?
The same, the angles are in the same spot.
They're basically in the same spot, right, with groups of 4. So when we say the groups of 4, remember, they have to be touching that transversal also. So one group of corresponding angles. 1 and 5 would work. What else? 3 and 7 would work. What else? 2 and 6. And each group of them are what to each other?
Even.
Identical or congruent again, right? Congruent. Okay? Questions there? I think we finally got them all. Everybody good with all that stuff?
Yes.
Okay? So, the next part was about congruent triangles. When we have congruent triangles, there's two different ways that we can show congruent triangles. One, we can draw the figures up here. And how do I show that the sides are congruent to the sides? The little slashes, right? How do I show the angles?
Circle things.
The little arcs, right? Okay. What's another way of showing that two triangles or two whatevers are absolutely congruent to each other?
Congruent statement.
A congruent statement, right? And so that statement, we say that triangle JKL is, what's the symbol for congruent?
Equal sign, no, legally.
Perfect. Triangle
ABC.
ABC. So this is a congruent statement, and it tells us just as much as that figure does, right? So what angle is congruent to angle K? What angle is, what side is congruent to JK?
AB.
AB. What angle is congruent to C?
L.
What side is congruent to BC?
KL.
Awesome. Everybody good?
An LG.
That makes sense to everybody? Okay. We skipped over transformations. So we go to quadrilaterals and polygons. What's a quadrilateral?
Four-sided shape.
Four-sided shape. And then we talked about polygons in general. What's a polygon? Just a shape, right?
Not a circle.
It can't have a curved part. What else does it have to have? It's got to be all connected, or it's got to be enclosed. So there we introduced those words, right? The prefixes. So if you forget the prefixes, we can always call a shape what?
Gone. Very gone.
Something gone, right? G-O-N. So we could say 12 gone, or we could say 6 gone. Now, from 3 to 10, we should really remember those prefixes, right? What was 3? Obviously a triangle. 4 then, we just said quadrilateral. 5, penta. 6, hexa. 7, hepta. 8, which is my stop sign. Remember, if it's not an 8-sided octagon, it's not really a stop sign. 9, nana, and 10, decagon, right?
12 is dodecagon.
Okay. So in a quadrilateral just says that it's definitely a 4-sided figure. Back in the old days when you were little, if somebody said a 4-sided shape, you probably said a rectangle, right? Well, now we have to call it a quadrilateral because we know that there's more different kinds of quadrilaterals. Okay, so in either case, if you look at section 10.4 here on the bottom of page 546, all 4 of my angles have to add up to what in a quadrilateral? 360 degrees. So you might have to do some of the math on that, right? So any problems with 19, 20, or 21? 20. So what do I have to do in 20? I'm going to write my problem, right? So what are my angles? Will you tell me to begin? 90, 78, 2x, x, and it has to equal, what did you tell me?
360.
360. Why is it 360? Because basically it could take every quadrilateral and cut it where? In half and make what?
2 triangles.
2 triangles. And we know that in one triangle it's 180, right? So I'm just taking all of my angles and setting them equal to 360 and then solving. What's 90 plus 78?
168.
168 plus, if I take 2x plus x, I get what?
3x.
3x. How do I solve for x?
Subtract.
Subtract 168.
Subtract 168. So what's 360 minus 168?
192.
15 minus
Yeah,
6.
192.
Perfect. Equals 3x. X equals, now I'm going to divide by 3. You ever divide it upside down? Have I ever showed you this?
No.
6, 18, 12. 312 is 4. Should have been 64. Is that right? So,
Yeah.
what is x? X is 64, but what are my angles? Well, this is actually an angle too, right? Because x was one of my angles, so 64, what's my other angle? What's 64 times 2? 128. And then hopefully this, and this all add up to 360 degrees. So if you wanted to check your answer, that's what you would do there. Make sense? So a lot of the time, like in number 19, when they ask you what is x and what is the angle, they are the exact same thing. So realistically, you don't have to say both answers, but don't forget this. Don't forget your little degree symbol too, whenever we're talking about angles.
So number 21, those two bottom angles would be the same thing.
Yes, sir. So I'm gonna do 220 plus 2x is equal to 360. Okay. Without looking at the next page, what is the formula to find the sum of all the angles inside any polygon?
S.
No,
No, S equals parentheses,
Whatever the sign.
And
whatever the number, yeah, the
S
number
minus
sign
S.
minus.
Okay, stop.
Okay,
One person.
S minus
S.
N.
What?
S minus N times 180.
It's
Equals
S equals
equals
N minus 2 times in parentheses times remaining.
Oh, that's
That's for N minus 1, then you divide by the original number.
that's okay. Is it
Right.
regular?
That's for if it's regular.
Okay, so what does it mean if it's regular versus irregular polygon?
Regular means every single line is the same group. Everything's
And
the same length and the same angle.
and the angles, right? So if it's regular, every length or the sides are all the same and the angles are all the same. Okay, so find out the sum of a 17-gon. Find the sum of all the interior angles of a 17-gon. Now, when you ask what I should do for writing down work, this is what I would expect in this one. That's me showing work at least. Okay? So what's 180 times 15?
2,700 degrees.
2,700?
Yep.
Squeeze that 700. How's that? Don't forget your degree symbol, like I said. Okay? Now, as Caleb brought up, if they asked you to find one individual angle of a regular 17-gon, now what do I have to do to this?
Divided by the number.
So I'm going to divide it by the number of sides. So 2,700 divided by 17, what do we get?
158.8, if you're gonna remember.
And then just make sure that you read the directions to see what you round to. Okay, so you only can do this if it's what kind?
Regular.
Regular. Okay? And how do you realistically know if it's regular? They should again put all those little slashes on it and all those arcs around it. Okay, they should do that. Otherwise, they should just say that it is. In this book right here, when it looks perfect like number 27, you have to just assume that that's what they're saying, even though that they didn't put it. Are there any other regular polygons in 25, 26, and 27?
No.
I wouldn't say so either, right? 25, what would we call 25?
Hexagon.
It's still a hexagon. 26,
7-gon.
a 7-gon or a heptagon, okay? And then we would go ahead and use that formula again. All right? So if you got a piece of paper out, otherwise find a little scratch piece of paper, okay? And we're going to talk about the formulas for area. Don't look, close your book right now. Okay, so we want to write the area of a parallelogram, a triangle, a trapezoid, and a circle on your piece of paper. The area of a parallelogram, triangle, trapezoid, and a circle.
Wait, do we still need the circumference or just areas?
And then, yeah, at the very end, do the circumference of a circle.
What's the
So you should have 5 total.
trapezoid?
Parallelogram, triangle, trapezoid, circle, and then the circumference of a circle.
How do you draw the pie section?
2 lines and then put that squiggly thing over the 2 lines down.
Look at the calculator, right there. Why does it look like that on the calculator?
What do you want it to look like? They just didn't really make it a squirrely one.
Yeah.
Alright, here we go. Parallelogram.
Base times height.
Little b times h, right? Triangle.
Oh, base times
one plus
height.
base two.
No.
That's
That's
the trapezoid. It's base times
Triangle.
height divided by
One
two.
half base times
Divided
height.
by two.
Yeah.
Base times height divided by 2, or somebody said 1/2 bh. Those are exactly the same thing, right? Just how you want to write it. Alright, now your trapezoid.
Base one plus base two divided by two in parentheses times height.
Perfect. Okay. A circle.
Radius squared times pi.
Pi r squared. Perfect. And circumference of a circle.
Diameter times pi or 2 times pi times radius. Let's go.
Okay? So those are our 5. Now, when we come back here and talk about a height and a base, every single time that you're looking for a base times a height, it should always form a what? A right angle. My base and my height should always form a right angle. And again, how do they have to show us that?
Box.
The box. Okay? Remember now, in my parallelogram, my triangle, my trapezoid, the height could be where?
Outside, inside.
Could be on the outside, it could be a part of the shape, it could be right down the middle of the shape. It doesn't matter. Okay, so remember when we have a triangle, that's what kind of triangle would we call this?
Isosceles? Oh, no, wait.
Scale.
Obtuse.
It's an obtuse triangle, right? Because this angle right here is way bigger. And so to make a height for an obtuse triangle, we'd make it out here somewhere, right? And they'd put a box. So again, when they tell us that the height is 9 feet and the side down here is 13 feet, even if it doesn't look like that, you got to go with it. Okay, meaning, does this look like it's shorter than this side? I don't know. But the question that I want, does 13 feet involve that right there?
No.
No. That part that's circled really doesn't mean anything to us. It just gets us out there so we can draw that right angle. Alright? So, then the last thing when we're talking about any of these areas, this last one's not an area. The first 4, my label has to be what? Squared. So centimeters squared, feet squared, whatever squared, right? And if they don't happen to use it like they showed in the assignment today, we'd say units squared. All right? What is circumference really?
Just the outside of the circle. I mean, outside of the circle.
So it's realistically, it's a perimeter, right? It's going all the way around the outside of the circle, so it's a perimeter. What's my label for that? What's my label for perimeter?
Just normal label.
Just the label, right? We don't square it. Okay? Remember now, instead of, if you don't want to use your calculator or use the button, what do we use for pi?
3.14.
3.14. So, look at 22, 23, 24, or 28, 29, and 30. And if you have any questions on any of those, we can do them on the board. So open your book back to page 547. And look at any of those, 22 through 24 and 28 through 30. Again now, when we're doing the area of a circle, make sure if they give you a diameter, the first thing you do is take it and divide it by 2. So, yeah, this book does a little better than the geometry book did. Telling if it's a diameter versus a radius. Go ahead.
Can we just do, example 24?
24. Okay. So 24 is basically something like that, right? So we have 8.7. Does it say 50 down here?
5.5.
5.0. Oh, 5.0. And what's my height?
6.2.
And they're all what? Meters? So again, make sure, I don't think I do this to you, but make sure from here on out that you always check that all of your labels are the exact same. Okay, if they're not the same, you got to turn them all into the same thing. So we got a trapezoid, right? What numbers are my bases? 5 plus 8.7. I'm taking my 2 bases, then I'm going to divide by 2 and multiply by 6.2. So again, if I put parentheses around it like this, I'm going to take 5 plus 8.7 divided by 2. That answer times 6.2. And then my answer would be
42.
meters squared. How much did you get?
42.47 meters squared.
4.7. And then make sure that you read the directions. Does it say here? Doesn't really say in this one, right? So it should say tomorrow and on Thursday what it's going to be. Okay. Make sense? Notice 23, we had another one of those triangles that are obtuse triangles. So that was kind of the example of that. And then like I said on the circles, on 30, the first thing that I need to do if I'm finding my area is to divide by 2. And then the last section is what we did for today. The irregular figures, so 31 through 33, are there any of those that freak you out and you want to look at? 33 freaks Carson out. Perfect.
The one example that they already showed, like the one that is like bent.
So kind of have an upside down ice cream cone in this one.
Looks like I have a speaker. Oh wait, I'm
34.
15.
Alright, so here's my figure. Honestly, this is probably kind of a poor thing from what we've been stressing because they didn't give us a what? They really didn't give us the box. So they really should put that, because if they don't put that, we don't know if that's truly a base and a height. So what do you think? What are you going to do for this one? What shapes do I have?
Triangle and a
Okay, so now, how many triangles do I have?
2.
2, right? I have this one and this one. Would you say they're the exact same triangle?
Yeah.
Yeah, because how do I know that for certain?
You can just make it one big triangle.
Okay, so I can make it one big triangle, or instead of, but how do I know that for certain that this triangle right here is the same as this triangle, even though that there's not a line right there?
Because they have the same, because they're split in half.
How do I know for certain that it's split in half? The reason that I could say this pretty confidently is because if it's the center of the circle, right? The center of the circle, meaning there's a dot in the middle, that tells me that that segment that they gave me is a what? What's that segment that they gave me? That they represent as 15 centimeters. What would we call that? A radius. And so if we extended it the other way, we would have another radius, right? So you could do it two ways. Like Nathan said, you could just make this line right here and then do base times height, because we would then know that the entire length of that would be how much? 30. Or you could do what? Well, I could do each individual one, but instead of dividing by 2, I'm multiplying by 2, because I'm taking this times this divided by 2 for this, but then I'm going to multiply it right back by that 2 because I have 2 of them. So that 1/2 and that 2 basically cancel each other out. If what I just said totally confused you, just do the 2 separate triangles. So I'm going to do 34 times 15 divided by 2, right? And then I'm going to take that answer and do what with it? I'm going to take this whole thing and multiply it by 2. Why do I multiply it by this 2? Because there's 2 of them.
Well,
Right?
we just don't need to do anything.
That's what I just explained. So notice that my 2's cancel each other out. But again, I had a lot of wide eyes, so that didn't make sense to some of you. So that's going to do me the top part of my ice cream cone. How do I get the ice cream?
Find area of a circle body, taking pi times radius squared.
So what's my radius? Squared, and then I'd have to do what to that?
225 times pi divided by 2.
Why am I dividing by 2? Because there's only half. And then I'm going to take this answer right here, this answer right here, and do what with them? Add them together. How much your grand total?
863.4 centimeters squared.
Anybody else get that?
Yeah.
Anybody else do it? Almost got purple on me.
Oh no.
863.4. You actually got it right there, big boy.
I think Grace just missed it barely. If you would have dropped out of her, she might have died.
She might have. Probably why she didn't come today. Alright, 31 or 32, any of those bother you? 31.
That's a speaker now.
That's a speaker?
Yeah.
Oh, okay, I see it now.
Yeah.
I get you. I was thinking it was more like a,
Microphone.
no, like a satellite that you would put
Oh,
up in
yeah.
space, and then you could like, they'd get it up there and then
Looks like an ice cream, like, once you get at Dairy Queen, a cone, they get at Dairy Queen or something.
Oh, if you flip it sideways, like the ones with like the waffle ones.
yeah. Alright, tell me that, this number.
7
7 what?
Inches.
inches.
Okay, what else? Down here?
7. Well, there's nothing there, but you know it's 7.
You do what?
Because it's all
But
separate.
it's all
Oh, it's
square,
not-
and it has boxes.
Did they have a box?
Yeah.
Okay.
On the
And
top.
on top too.
Okay. Did they give me this?
Yes.
Yes. 6.
Did they give me this?
6.
Oh.
6 was this, right?
Yeah.
And then
It's still 7.
That's all.
Okay, that's all they really give us? So, what's this shape?
Square.
It's definitely a square, right? Any arguing about that?
No.
So, can I still call this a quadrilateral?
Yes.
Can I call this a parallelogram?
Yeah.
Can I call this a rectangle?
No. I mean, yes.
Yes.
A rectangle is a square, or a square is a rectangle?
Square is a
Square is a rectangle, right? Why can't a rectangle be a square?
Because it's not even all the way.
Because they don't have the same lengths. Alright, so what do we have? What shapes do we have?
Square is a trapezoid.
A square and a trapezoid, really, right?
Rectangle and a trapezoid.
Okay, so what am I doing for my square? 7 times 7, right? Again, this is me showing work. What am I going to do for this?
7 plus 16 divided by 2 times 6.
Perfect. 7 plus 16 is how much?
23.
23 divided by 2?
11.5.
11.5 times 6.
60.
69 plus 49.
118.
118 what?
That's
Inches square.
Everybody agree?
Yep.
Everybody see how we got all that stuff?
Yeah.
I almost did that in my head, but it
must have got dull like your pencil was at the beginning of the period.
No, I have a short line, BB.
Questions?
What do you do?
I think about 80.
Everybody good?
Yeah.
So, quite a bit of